Welcome, dear listener. Thank you for joining me once again in this quiet corner of the night, where the world outside settles into stillness and the gentle rhythm of learning can wash over you like a warm tide. I am the sleepy professor, and tonight, as autumn deepens around us, or perhaps spring awakens, depending on where you find yourself on our tilted world, I invite you to make yourself comfortable. Let your breathing slow, let your shoulders drop, and allow your mind to drift with me on a journey through one of Earth's most beautiful secrets. The way our planet breathes with the seasons. Think for a moment about the breath in your own body, in and out, steady and rhythmic, so natural you rarely notice it, yet without it, life would cease. Now imagine that our entire planet breathes in much the same way, not with lungs but with light and shadow, with the slow turning of days and the patient progression of months. This is the breath of seasons, a rhythm so vast and gentle that it shapes everything, the color of leaves, the migration of birds, the planting of crops and the celebrations of human cultures across the globe. Perhaps you are listening from a place where winter's first chill has begun to touch the air, where trees stand bare against a pale sky. Or maybe you're in a land where spring flowers are just beginning to push through the earth, carrying promises of warmth and renewal. Wherever you are part of this grand breathing, this slow inhale and exhale that has been going on for billions of years, long before humans walked the earth, and will continue long after we are gone. If this gentle exploration brings you comfort as you prepare for sleep, you're welcome to let it carry you there. The seasons themselves are teachers of rest and renewal, of the wisdom in cycles of activity and dormancy. And if you find value in these quiet journeys, a like or subscription helps these conversations reach other listeners who might find solace in the night. But my deepest hope is simply that you feel held by the rhythm we'll explore together, the same rhythm that rocks our planet gently through space and time. As we begin, let me share something that might seem strange at first. The reason we have seasons has almost nothing to do with how close or far Earth is from the sun. This is one of the most common misconceptions about our world, and it's understandable after all. Don't we feel colder when we step away from a fire? But Earth's distance from the sun changes very little throughout the year, only about 3%. If distance were the primary factor, the entire planet would experience the same season at the same time. Instead, while it's winter in New York, it's summer in Sydney. While autumn leaves fall in London, spring blossoms open in Buenos Aires. The true secret of seasons lies not in distance, but in tilt. Our planet is tilted on its axis by about 23.5 degrees, like a spinning top that's been nudged gently to one side. Imagine holding a flashlight and shining it on a globe that's been tilted. The light hits different parts of the globe at different angles. When the northern hemisphere tilts toward your flashlight, it receives more direct light and warmth. This is summer. When it tilts away, the light strikes at an angle, spreading out and weakening. This is winter. The southern hemisphere experiences the opposite, creating a beautiful symmetry where Earth's two halves breathe in opposite rhythms. This tilt is not random. It's the result of an ancient collision billions of years ago, when a Mars-sized object crashed into our young planet. From this cosmic catastrophe came our moon, and from it came the gentle tilt that gives us seasons. What could have been destruction became creation, violence became rhythm, chaos became the gentle breathing that makes our world so alive and varied. But the story of seasons is not simply about tilt and light. It's about the intricate ways that life responds to this cosmic rhythm, and how humans have learned to read the sky and calendar their lives by the subtle changes in day and night. For in the dance of seasons lies also the dance of time itself, the lengthening and shortening of days that marks the passage of the year with more precision than any human-made clock. At the heart of seasonal change lies the journey of light. As Earth orbits the sun with its gentle tilt, different parts of our planet receive varying amounts of daylight throughout the year. This is not merely a matter of brightness, but of time itself. The very length of day and night shifts in a slow, predictable rhythm that has guided life for eons. The summer solstice marks the peak of this cycle in each hemisphere. In the northern lands, around June 21st, the sun climbs to its highest point in the sky, and daylight stretches to its maximum length. In places like Norway or Alaska, the sun may barely set at all, creating the ethereal phenomenon of the midnight sun. The world seems to hold its breath in these long days, as if reluctant to let the light fade. Plants stretch toward the endless sun, animals remain active far into what should be night, and humans often feel energized by the abundance of light, their sleep patterns shifting to match the sky's reluctance to darken. 6 months later, the winter solstice brings the opposite extreme. Days grow short, and nights stretch long, particularly in the northern reaches where the sun may barely rise above the horizon. In some places, it doesn't rise at all, creating the polar night that wraps the land in a months-long twilight. Yet this is not a time of death, but of deep rest. Trees stand dormant, their energy conserved in root and trunk. Animals hibernate or slow their metabolism. Even humans often feel the call to quiet contemplation, to longer sleep, to gathering close to warmth and light. Between these extremes lie the equinoxes, those two perfect moments each year when day and night stand in precise balance across the entire Earth. The spring equinox brings the promise of returning light, each day growing minutely longer than the last. The autumn equinox carries the opposite message, a gentle warning that darkness is coming, time to prepare, time to gather and store and settle in for the quiet months ahead. This rhythm of light and darkness is so fundamental that it has written itself into the very cells of nearly every living thing. Plants measure the length of nights to know when to bloom or when to drop their leaves. Birds sense the changing light to time their migrations across thousands of miles. Even bacteria deep in the ocean, far from any direct sunlight, carry circadian rhythms that echo the daily and seasonal cycles above. For humans, this rhythm runs deeper than we often realize. Our bodies produce more melatonin during the long nights of winter, encouraging rest and introspection. Our vitamin D levels fluctuate with sun exposure, affecting not just bone health but mood and energy. Many people experience seasonal affective disorder during the darkest months, their bodies struggling to adapt to the reduced light, while others feel most alive and creative during these contemplative periods. Ancient peoples read these changes with the attention of those whose very survival depended on understanding the sky. They knew that when the sun reached a certain point on the horizon, it was time to plant. When the days began to shorten noticeably, it was time to harvest. When the evening star appeared in a particular constellation, winter was coming. These observations were not mere curiosities, but essential knowledge, passed down through generations in songs, stories, and stone monuments, aligned to catch the light at precisely the right moments. The megalithic builders of Stonehenge oriented their great stones to frame the sunrise on the summer solstice, creating a cosmic calendar carved in stone. The Maya built pyramids whose shadows marked the equinoxes with mathematical precision. In Peru, the Inca created Intihuatana stones, hitching posts of the sun, designed to track the solar year and ensure that the sun would return from its winter retreat. Even today, when electric lights can extend our days and international trade can bring us summer fruits in winter, we light candles in December darkness, celebrate the return of spring with festivals of flowers, mark the summer with gatherings under long twilight skies, and welcome autumn with harvest festivals that echo celebrations as old as agriculture itself. This precision has been refined over millions of years of evolution, creating a global symphony of seasonal response that connects Arctic terns to Antarctic waters, connects the flowering of plants in Europe to the timing of bird migration from Africa, connects the spawning of fish in tropical seas to the movement of ocean currents driven by seasonal ice melt in polar regions. To witness this great seasonal transformation is to see evolution in action, to understand that what we call nature is not a static thing but a dynamic response to the cosmic rhythm of our tilted planet spinning around the sun. Every migration, every hibernation, every leaf that turns colour and falls is both ancient and immediate, ancient in that these patterns have been refined over geological time, immediate in that they are happening now, this year, this season, as the earth continues its eternal dance with light and shadow. Humans, too, are part of this great seasonal symphony, though we sometimes forget it in our climate-controlled buildings and year-round grocery stores. But our ancestors knew it intimately, and they wove this knowledge into the very fabric of civilization. The story of human civilization is, in many ways, the story of learning to read the seasons and dance with their rhythm. Before there were written calendars, before there were clocks, there was the slow turning of the sky and the patient observation of those who noticed that certain stars appeared at harvest time, that the angle of shadows at noon slowly shifted, that birds and flowers and weather followed patterns that repeated with reliable precision. Agriculture itself was born from this understanding. The transition from hunter-gatherer societies to farming communities required not just the domestication of plants and animals, but the domestication of time itself, learning to plant in rhythm with the seasons, to store grain through winter, to trust that spring would return and bring with it the conditions for new growth. In ancient Mesopotamia, one of the cradles of agriculture, farmers learned to time their planting with the heliacal rising of certain stars, the moment when a star first becomes visible, just before dawn after having been hidden by the sun's glare. The appearance of the Pleiades cluster in the pre-dawn sky signaled that the flood season of the Tigris and Euphrates rivers was approaching, time to prepare the fields for planting. This was not mere superstition but practical astronomy, encoded in myths and stories that helped preserve essential knowledge across generations. The ancient Egyptians similarly timed their agricultural year to the flooding of the Nile, which itself followed seasonal patterns linked to monsoon rains thousands of miles away in the Ethiopian highlands. They noticed that the heliacal rising of the star Sirius coincided with the annual flood, and they built this observation into their calendar and religious practices. The goddess Isis was associated with Sirius, and her tears were said to cause the life-giving flood that fertilized the land. In Europe, the Celtic year was divided into 8 festivals marking the seasonal transitions. Imbolc, celebrated at the beginning of February, marked the first stirrings of spring when ewes began to lactate and the first flowers appeared. Beltane, on May 1st, celebrated the full arrival of spring and the time of planting. Lughnasadh in August marked the beginning of harvest, while Samhain at the end of October honoured the end of the agricultural year and the beginning of winter. These were not arbitrary dates, but careful observations of seasonal phenomena. Imbolc falls roughly halfway between the winter solstice and the spring equinox, when daylight is noticeably lengthening and the first signs of spring become apparent. Samhain similarly marks the midpoint between autumn equinox and winter solstice, when the last harvests are complete and winter preparations must be finished. The precision of these seasonal observations is preserved in ancient monuments like Newgrange in Ireland, built over 5,000 years ago. Its entrance is oriented so that on the winter solstice, and only on the winter solstice, the rising sun illuminates a passage and chamber deep within the mound. For 17 minutes, light penetrates the darkness, marking the exact moment when the days begin to lengthen again, a stone calendar that has kept perfect time for millennia. Similar precision appears in monuments worldwide. The Angkor temples in Cambodia are aligned to seasonal positions of the sun and stars. The Pyramid of Kukulkan at Chichen Itza in Mexico creates a serpent shadow that crawls down its steps precisely at the equinoxes. In Peru, The Nazca lines include features that point to the sun's position at various seasons, while Machu Picchu contains the Intihuatana stone carved to track the sun's annual journey across the sky. These were not merely religious or ceremonial structures, but functioning calendars that helped entire civilizations coordinate their agricultural activities. The survival of communities depended on getting the timing right. Planting too early risked crops being killed by late frost. Planting too late meant shortened growing seasons and reduced yields. This seasonal knowledge shaped not just when to plant, but what to plant where. Indigenous peoples of North America developed the Three Sisters agricultural technique, planting corn, beans, and squash together in a pattern that maximized their mutual benefits and matched their seasonal growth patterns. The corn provided a natural trellis for the beans, which in turn fixed nitrogen in the soil that fed the corn and squash, while the large squash leaves shaded the ground to retain moisture. In the Andes, people learned to cultivate crops at different elevations, creating a seasonal calendar that moved up and down the mountainsides. They would plant potatoes first in the valleys, then progressively higher as the growing season advanced, and harvest in the same sequence. This vertical agriculture allowed them to extend the growing season and reduce the risk of crop failure from unpredictable weather. The seasonal timing of agriculture also created the need for food storage and preservation techniques. Root cellars, grain silos, and fermentation methods all developed as ways to bridge the gap between harvest and the next growing season. The ability to preserve food through winter was what allowed human settlements to grow beyond the immediate capacity of the land to support them. Seasonal patterns influenced not just agriculture, but also trade and communication. In many parts of the world, major trading expeditions were timed to seasonal weather patterns. In the Indian Ocean, traders learned to use the monsoon winds, sailing northeast with the winter monsoon and returning southwest with the summer monsoon, completing round trips that could take an entire year. In northern regions, frozen rivers and lakes became seasonal highways, allowing trade and communication across vast distances that were impassable during summer. The fur traders of North America timed their expeditions to these winter routes, while in Russia, the seasonal freeze of rivers allowed trade connections between distant cities. Even warfare followed seasonal patterns. Most medieval campaigns were conducted in summer when roads were passable, crops could be foraged, and soldiers could sleep outdoors. The campaign season was a real thing, bookended by the practical necessities imposed by winter weather. Napoleon's disastrous retreat from Moscow was largely due to his failure to account for the early onset of Russian winter, while Washington's crossing of the Delaware was timed to take advantage of winter conditions that made the river crossable and his enemies complacent. The seasonal cycle also shaped human social life and cultural practices. In agricultural societies, winter was often a time for indoor crafts, storytelling, and community activities, while summer was devoted to intensive outdoor work. Wedding seasons, festivals, and religious observances were often timed to agricultural cycles, harvest festivals celebrating abundance, spring festivals celebrating renewal, winter festivals celebrating community and the promise of returning light. This seasonal awareness created a different relationship to time than we have today. Rather than the mechanical regularity of clocks and calendars, time was organic and cyclical, measured by the subtle changes in daylight, the behavior of animals, the progress of plants, and the position of stars. People lived more deeply embedded in seasonal rhythms, their activities, their moods, and even their diets changing with the turning of the year. The knowledge required to live this way was vast and complex, passed down through generations in the form of farming almanacs, folk wisdom, seasonal festivals, and oral traditions. Much of this knowledge has been lost in our modern urbanized world, but its traces remain in the seasonal foods we still crave, the holiday traditions we still observe, and the subtle ways our bodies and minds still respond to the ancient rhythm of light and shadow. Even today, in our globally connected world, agriculture still follows seasonal patterns, and weather still affects transportation, energy use, and countless other aspects of human life. We may have electric lights and heated buildings, but we remain creatures of a tilted planet, still breathing with the great seasonal rhythm that has shaped life on Earth for billions of years. To understand the seasons is to understand something fundamental about the relationship between Earth and Sun, between cosmic mechanics and daily life, between the grand patterns of astronomy and the intimate details of when to plant a seed, when a bird will sing, when a tree will bloom. It is to see that we are all part of a vast seasonal symphony, conducted by the gentle tilt of our planet as it orbits the Sun, a symphony that has been playing since long before humans existed and will continue long after we are gone. But the seasons we experience today are not the seasons that have always been. The Earth's climate has breathed with longer, deeper rhythms across millions of years, creating periods so different from our current world that they challenge our very definition of what seasons can be. These are the ice ages, vast seasonal cycles written not in months but in millennia, where the planet itself seems to inhale and exhale ice across entire continents. To understand ice ages, we must first grasp that the Earth's orbital patterns themselves change over long periods of time. The tilt that gives us our yearly seasons is not constant. It oscillates between 22.1 and 24.5 degrees over a cycle of about 41,000 years. Our orbit around the Sun is not a perfect circle but an ellipse, and the shape of this ellipse changes over a 100,000-year cycle. Even the wobble of Earth's axis, like a spinning top gradually shifting its orientation, follows a rhythm of about 26,000 years. These slow changes, known as Milankovitch cycles after the Serbian astronomer who calculated them, combine to create periods when the northern hemisphere receives significantly less summer solar radiation. When this happens, snow that falls in winter doesn't completely melt in summer. Year after year, it accumulates, compacting into ice, spreading outward from centers in Canada, Scandinavia, and Siberia until vast sheets of ice cover continents. During the peak of the last ice age, about 20,000 years ago, ice sheets over a mile thick covered much of North America down to what is now New York and Chicago. In Europe, ice extended from Scandinavia, across the Baltic Sea, and down into what is now Germany and Poland. So much water was locked in ice that sea levels were 400 feet lower than today, exposing land bridges that connected continents and allowed migrations of both animals and humans that would be impossible now. The scale of these ice age seasons is almost incomprehensible. Individual ice sheets contained more water than all of today's rivers and lakes combined. The weight of the ice was so great that it pressed the land beneath it down by hundreds of feet, a process called isostatic depression that we can still measure today as formerly glaciated regions slowly rebound, rising measurably each year as they recover from the weight of long melted ice. But ice ages were not uniformly cold periods. They were punctuated by interglacials, relatively warm periods like the one we're in now when the ice retreated and temperate conditions returned to high latitudes. These interglacials typically lasted 10,000 to 12,000 years, brief warm breaths between the longer, colder cycles. We are currently about 11,700 years into the current interglacial, which began at the end of the last ice age and allowed human civilization to develop. The transition between glacial and interglacial periods was often surprisingly rapid. Ice core data from Greenland shows that temperatures sometimes rose by 15 degrees Fahrenheit in just a few decades. The great ice sheets that had taken thousands of years to build could collapse relatively quickly, sending enormous volumes of meltwater into the oceans, raising sea levels and dramatically altering global weather patterns. These climate changes had profound effects on life. During glacial periods, forests retreated toward the equator, replaced by tundra and grassland. Many animal species adapted by migrating with their preferred habitats or by evolving to cope with colder conditions. Others became extinct when they couldn't adapt quickly enough to the changing conditions. For early humans, ice ages created both challenges and opportunities. The lowered sea levels exposed land bridges that allowed human migration from Asia to the Americas, across what is now the Bering Strait. The expanded grasslands supported large herds of mammoth, bison, and other megafauna that became the basis for hunting cultures. But the harsh conditions also drove technological innovation. The development of sophisticated tools, clothing, and shelter techniques that allowed humans to survive in environments that would have been uninhabitable to their ancestors. Cave paintings from Ice Age Europe show how humans observed and adapted to these long seasonal changes. The animals they depicted, woolly rhinoceros, cave bears, herds of reindeer, were all adapted to the cold grasslands and tundra that characterized glacial Europe. When the Ice Age ended and forests returned, these animals either migrated north or became extinct, replaced by the temperate forest species we know today. The end of the last Ice Age also coincided with, and may have helped trigger the development of agriculture. As the climate stabilized and warmed, wild grains became more abundant and predictable in their seasonal cycles, making it worthwhile for humans to stay in one place and eventually begin cultivating crops. The reliable seasonal patterns we take for granted today may have been less predictable during the chaotic climate transitions at the end of the Ice Age. Ice ages also left behind dramatic evidence of their seasonal power. The landscape of much of northern Europe and North America was sculpted by moving ice. The U-shaped valleys of Yosemite, the Great Lakes, the fjords of Norway, the drumlin hills of New England. Enormous boulders called glacial erratics were carried hundreds of miles by ice and left stranded on hillsides when the glaciers retreated, like geological calling cards from this deep seasonal past. Even today, we can see evidence of Ice Age cycles in the annual layers of ice preserved in Antarctica and Greenland. These ice cores contain bubbles of ancient atmosphere, allowing scientists to measure not just temperature changes, but also atmospheric composition going back hundreds of thousands of years. They reveal that ice ages followed complex patterns, with smaller-scale climate variations nested within the larger glacial cycles. Seasons within seasons within seasons, like Russian dolls of climate change. The ice cores also show that our current interglacial period has been unusually stable compared to earlier ones. Previous interglacials showed more variability, with temperatures fluctuating significantly within periods that were already brief compared to the glacial periods. This stability may have been crucial for allowing human civilization to develop. Agriculture and complex societies require predictable seasonal patterns, and the remarkable consistency of our current interglacial may have provided the stable foundation that human culture needed to flourish. Understanding ice ages also provides perspective on current climate change. While human activities are warming the planet much more rapidly than natural processes, the geological record shows that Earth's climate has experienced dramatic changes throughout its history. Ice ages remind us that the seasonal patterns we consider normal are actually just one phase of much longer cycles, and that the planet's climate system is capable of dramatic transformations that can reshape continents and redirect the course of evolution itself. The next ice age, if natural cycles continue undisturbed, might not be due for tens of thousands of years, but the relationship between ice ages and seasonal cycles shows how small changes in orbital patterns can have enormous consequences over long time periods. The tilt and wobble that give us our yearly seasons are part of much larger celestial mechanics that operate on timescales that dwarf human history, but still shape the world we inhabit. Ice ages are perhaps the ultimate expression of Earth's seasonal nature, proof that our planet breathes not just annually, but across geological time, inhaling and exhaling ice and warmth in cycles so vast that mountain ranges rise and fall within them. They remind us that the gentle seasonal changes we experience each year are part of a much larger symphony of climate change, one that has been playing since Earth first acquired its atmosphere and will continue long after human civilization has become part of the geological record. To stand on a glacier today, one of the last remnants of the great ice age cycles, is to touch deep time itself, to feel the slow breath of a planet that measures seasons not just in months but in millennia. The ice beneath your feet contains layers of snow that fell when mastodons walked the earth, when human beings first learned to make fire, when the outline of continents was different from what we see today. It is a library of seasons written in ice, a record of how our tilted planet has danced with the sun across the vast stretches of geological time. As the great ice sheets retreated and our current interglacial period began, humans found themselves in a world with more predictable seasonal patterns than Earth had experienced for tens of thousands of years. This climatic stability coincided with, and perhaps enabled, one of the most remarkable developments in human history: the birth of agriculture and the seasonal festivals that celebrate it. The story of how humans learned to read the seasons and celebrate their turning is also the story of how we became civilized, not in the sense of being more refined, but in the literal sense of forming lasting settlements, developing complex societies, and creating cultural traditions that could be passed down across generations. The seasonal festivals that still mark our calendars today are echoes of this ancient partnership between human culture and the rhythms of the tilted earth. Consider the spring festivals that emerge independently across cultures worldwide. In ancient Mesopotamia, the New Year celebration of Akitu marked the spring equinox and the beginning of the planting season. For 11 days, the community would reenact the creation myth, symbolically dying with winter and being reborn with spring. The king would be ritually humiliated and then restored, representing the death of the old year and the birth of the new. These were not merely religious ceremonies, but practical celebrations that coordinated community-wide agricultural activities and reinforced the social bonds necessary for successful farming. In ancient Greece and Rome, spring brought festivals honoring Persephone's return from the underworld. According to myth, Persephone's annual journey between the world of the dead and the world of the living explained why winter came and went. Her absence brought barrenness, her return brought flowers and grain. The Eleusinian mysteries, celebrated for nearly 2,000 years, used this myth to explore themes of death and rebirth that resonated deeply with agricultural peoples who saw these cycles enacted in their fields each year. The Celtic festival of Beltane, celebrated on May 1st, marked the true arrival of spring when cattle could safely be driven to summer pastures. Communities would light great bonfires and drive their animals between them, believing this would protect them from disease and ensure fertility throughout the summer months. Young people would spend the night in the woods, gathering flowers and branches to decorate their homes and communities, celebrating the return of life to the land. These traditions survive today in May Day celebrations, Morris dancing, and the crowning of May Queens, rituals that may seem quaint now, but once carried the weight of community survival through another year. Summer festivals celebrated abundance and the peak of the agricultural year. The summer solstice brought celebrations of light and fire across Europe. In Scandinavia, midsummer celebrations included bonfires that burned all night during the season when darkness never fully came. These fires were believed to strengthen the sun at its peak power and ensure that its light would not fail during the coming winter. People would gather herbs on Midsummer's Eve, believing they possessed special healing powers when picked at the moment of the sun's greatest strength. The harvest festivals of autumn may be the most universal of all seasonal celebrations. Found in virtually every agricultural society, these celebrations served multiple functions. They gave thanks for the year's abundance. They coordinated community-wide harvesting activities, and they prepared communities psychologically and practically for the coming winter. The Jewish festival of Sukkot, the Hindu festival of Pongal, the Chinese Mid-Autumn Festival, the European Harvest Home celebrations, and the American Thanksgiving all share this common thread of gratitude and preparation, celebrating the successful completion of another agricultural cycle. Winter festivals, perhaps paradoxically, often became the most elaborate and meaningful of all. When the natural world entered its period of dormancy, human communities turned inward, creating celebrations that sustained morale and reinforced social bonds during the darkest months. The Roman Saturnalia, the Germanic Yule, the Persian Yalda Night, and countless other winter festivals shared common elements: the lighting of fires and candles to symbolically call back the sun, feasting that used stored food to celebrate survival, and gift-giving that strengthened community relationships when cooperation was most essential. The winter solstice became a particularly powerful moment in many cultures, the longest night after which daylight would slowly return. This astronomical event required no complex calculations to observe. Anyone could notice that the days had been getting shorter and would, after this night, begin to lengthen again. It was a promise written in the sky that winter would not last forever, that the cycle would turn, that spring would return. These seasonal festivals were not just social events but sophisticated technologies for synchronizing human communities with natural cycles. They served as communal calendars, marking the optimal times for various activities. They preserved and transmitted essential knowledge about seasonal timing through ritual, song, and story. They provided psychological support during difficult periods and channeled community energy toward essential tasks. Many of these ancient seasonal celebrations persist today, though their agricultural origins are often forgotten. Christmas incorporates elements of multiple winter solstice festivals, including the Germanic tradition of bringing evergreen trees indoors and the Roman custom of gift-giving during Saturnalia. Easter combines the timing of Jewish Passover with spring fertility symbols like eggs and rabbits. Halloween traces back to the Celtic Samhain, marking the end of the harvest and the beginning of winter's dark half of the year. Even in our urbanized, globalized world, these seasonal celebrations continue to provide rhythm and meaning to human life. We may no longer depend directly on seasonal agricultural cycles for survival, but we still feel the pull of these ancient rhythms, still gather with family during the winter holidays, still feel renewal in spring festivals, still celebrate abundance in autumn harvests. The persistence of seasonal festivals across cultures and millennia suggests something fundamental about human nature and our relationship to the cosmic rhythms that govern our planet. We are seasonal creatures, shaped by millions of years of evolution under the influence of Earth's tilted axis and its dance around the sun. Our bodies still respond to changing daylight, our moods still shift with the seasons, and our spirits still need the markers and celebrations that connect us to cycles larger than our individual lives. Understanding these seasonal festivals, both their practical origins and their enduring appeal, helps us see how deeply humans are embedded in the natural world, despite our technologies and urban lifestyles. We carry within us the wisdom of countless generations who learned to read the sky, to time their activities to natural rhythms, and to find meaning and celebration in the eternal return of the seasons. The festivals also remind us that seasonal change is not just about individual adaptation, but about community response. Humans developed culture as a way of sharing seasonal knowledge, coordinating group activities, and supporting each other through the challenges and opportunities that each season brings. In this sense, seasonal festivals are one of humanity's earliest and most enduring technologies, social technologies that helped our species not just survive, but thrive in partnership with the rhythms of our tilted planet. Today, as we face rapid climate change an increasing disconnection from natural cycles, these seasonal traditions may be more important than ever. They remind us that we are part of a larger system, that our well-being is connected to the health of the planet's seasonal rhythms, and that celebration and ritual can help us maintain our connection to cycles that are much larger and older than our individual lives. The festivals of the seasons are therefore not quaint remnants of a primitive past, but sophisticated expressions of human wisdom about how to live in harmony with cosmic rhythms. They represent thousands of years of human experimentation with how to create meaning, community, and continuity in the face of constant change. They are humanity's attempt to dance with the seasons rather than simply endure them, to find joy and purpose in the eternal turning of the year. And yet, as we celebrate these seasonal festivals and observe the annual changes in our local environments, it's worth remembering that our experience of seasons is just one movement in a much larger symphony. The seasonal cycles that seem so fundamental to our existence are themselves nested within longer, deeper rhythms that operate on timescales that challenge human understanding. We have already explored how ice ages represent seasons of the deep past, but Earth's climate has breathed with even longer rhythms, patterns that unfold over millions and even hundreds of millions of years, driven by forces that dwarf even the mighty Milankovitch cycles that bring ice ages. Consider the story of Earth's atmospheric oxygen levels over the past billion years. During what geologists call the Carboniferous period, about 300 million years ago, oxygen levels were much higher than today, perhaps 35% of the atmosphere compared to today's 21%. This oxygen-rich atmosphere allowed insects to grow to enormous sizes. Dragonflies with 2-foot wingspans buzzed through forests of giant ferns and early trees. It was a seasonal cycle of atmospheric chemistry, driven by the burial of vast amounts of organic matter in swamps that would eventually become coal deposits. Later, during the Permian period about 250 million years ago, Earth experienced the greatest mass extinction in its history. Over 90% of marine species disappeared, possibly due to massive volcanic eruptions in what is now Siberia that pumped enormous quantities of greenhouse gases into the atmosphere. The planet warmed dramatically, the oceans became acidic and oxygen poor, and life came closer to complete extinction than at any other time in Earth's history. Yet life survived, recovered, and diversified into new forms, another breath in Earth's longest seasonal cycle. During the Cretaceous period, about 100 million years ago, Earth was so warm that there was no ice even at the poles. Tropical forests grew in Antarctica, and sea levels were hundreds of feet higher than today. Dinosaurs roamed lush landscapes that extended from equator to pole, while flowering plants were just beginning their spectacular diversification. This was Earth's greenhouse season, a time when the planet's climate system operated in modes we can barely imagine today. These deep climate cycles were driven by forces operating on geological timescales, the slow drift of continents that changed ocean circulation patterns, massive volcanic eruptions that altered atmospheric composition, the gradual brightening of the sun over billions of years, and even asteroid impacts that temporarily threw the climate system into chaos. The movement of continents themselves creates a kind of seasonal breathing over hundreds of millions of years. When continents cluster together into supercontinents like Pangaea, they create different climate patterns than when they spread apart as they are today. Supercontinents tend to create more extreme seasonal variation, hotter summers and colder winters, because their massive interiors are far from the moderating influence of oceans. Even life itself has been a driver of these deep seasonal cycles. The evolution of photosynthesis about 2.4 billion years ago pumped so much oxygen into the atmosphere that it caused a mass extinction of anaerobic organisms, an event called the Great Oxidation Event. Later, the evolution of large land plants created another atmospheric shift by removing carbon dioxide from the air and burying it as organic matter, contributing to ice ages during the Carboniferous period. These deep-time climate cycles remind us that the seasonal patterns we consider normal are actually just a brief moment in Earth's much longer climate story. Our current ice age cycle, our current atmospheric composition, our current continental arrangement, all of these are temporary phases in Earth's continuing evolution. This perspective can be both humbling and comforting. Humbling because it reminds us how contingent our existence is on a particular set of climate conditions that have persisted for only a tiny fraction of Earth's history. Comforting because it shows that Earth's climate system, while capable of dramatic changes, has always found new equilibrium states, and life has always found ways to adapt and diversify. Understanding deep-time climate cycles also provides context for current climate change. While human activities are warming the planet much faster than most natural processes, the geological record shows that Earth's climate has experienced rapid changes before and has always eventually stabilized in new configurations. This doesn't minimize the challenges that rapid climate change poses for human civilization and current ecosystems, but it does suggest that Earth's climate system is resilient over long timescales. The deep time perspective also reveals that our current interglacial period, the stable climate that has allowed human civilization to develop, is itself an unusual and temporary phase. For most of the past 2 million years, Earth has been in glacial periods with climates very different from what we experience today. Our stable Holocene climate represents less than 1% of recent Earth history, a brief seasonal pause between much longer periods of ice and cold. This raises profound questions about the future. Are we living in the last natural interglacial before the next ice age, or has human influence on the climate system become so strong that we have fundamentally altered Earth's seasonal breathing? Some scientists suggest that human carbon emissions may delay or prevent the next ice age, effectively extending our current interglacial indefinitely. In this view, humans have become a geological force comparable to continental drift or massive volcanism, capable of steering Earth's climate system into new configurations that have no precedent in the geological record. We may be creating a new kind of season in Earth's deep time breathing, an Anthropocene epoch characterized by human influence on global climate cycles. The story of Earth's deep seasonal breathing also connects our planet to the broader cosmos. The gradual brightening of the sun over billions of years has been a major driver of long-term climate change. In about 1 billion years, the sun will have brightened to the point where Earth's oceans may begin to evaporate, ending the water cycle that has sustained life for so long. Even our sun has its own seasonal cycles, operating on timescales that encompass the entire history of life on Earth. Understanding these deep time cycles doesn't diminish the importance of annual seasons or human seasonal celebrations. Instead, it places them in a larger context, showing how the rhythms that govern our daily lives are part of ever larger cycles that stretch from the rotation of our planet to the evolution of our solar system. We are seasonal creatures living on a seasonal planet orbiting a seasonal star in a universe that itself may be seasonal on timescales we can barely contemplate. The annual cycle of seasons that we experience, spring renewal, summer growth, autumn harvest, winter rest, is therefore both intimate and cosmic. It connects us to the tilted spinning of our planet, to the orbital mechanics that govern our solar system, to the deep time breathing of Earth's climate, and ultimately to the vast cycles that govern the entire universe. Every spring flower that blooms, every autumn leaf that falls, every winter night when we light candles against the darkness, is part of this nested hierarchy of seasons, within seasons, within seasons. To understand how Earth breathes is to understand our place in a universe that operates through rhythm and cycle, change and return, breathing in and breathing out across every scale from heartbeats to the expansion of the cosmos itself. We are not separate from these cycles, but embedded within them, our lives taking their rhythm from the tilted dance of our planet with the sun, our cultures shaped by our attempts to read and celebrate and live in harmony with these cosmic seasonal patterns. The seasonal festivals of humanity are therefore not just quaint traditions but profound expressions of our connection to universal rhythms, our attempts to dance with forces much larger than ourselves, to find meaning and community and celebration in the eternal turning of cycles that began long before we existed and will continue long after we are gone. In lighting candles at winter solstice, in planting seeds at spring equinox, in gathering harvests in autumn, we participate in a cosmic ritual that connects us to every creature that has ever lived on this tilted, breathing planet. Modern life often obscures our connection to seasonal rhythms. Electric lighting extends our days beyond what the sun provides. Global trade brings us strawberries in winter and hot soup in summer. Climate-controlled buildings maintain constant temperatures regardless of the weather outside. We can live our entire lives without directly experiencing the daily and seasonal cycles that shaped our ancestors' existence. Yet beneath our technological insulation, the seasonal rhythms continue to influence us in ways both subtle and profound. Our bodies still produce melatonin in response to darkness, still crave different foods as seasons change, still feel the pull of seasonal moods and energy levels. Children still delight in the first snow, the first spring flowers, the long days of summer vacation. Even urban dwellers find themselves drawn to seasonal activities: ice skating in winter, picnics in summer, apple picking in autumn. This persistent connection to seasonal rhythms suggests something fundamental about human nature. We evolved as seasonal creatures, and millions of years of evolution don't disappear in the few centuries since the Industrial Revolution. Our genes still carry the wisdom of ancestors who survived ice ages, who learned to read the sky for planting times, who celebrated seasonal transitions as matters of life and death. Understanding our seasonal nature can help us live more harmoniously with our own rhythms and needs. Instead of fighting against seasonal changes in mood and energy, we might learn to work with them. Winter's inclination toward rest and reflection might be honored rather than medicated away. Spring's burst of energy and optimism might be channeled into new projects and relationships. Summer's abundance might be celebrated and shared. Autumn's contemplative mood might be used for evaluation and planning. Many traditional cultures had sophisticated understandings of how human activity should align with seasonal rhythms. Traditional Chinese medicine recognizes that different organs and systems are most active during different seasons and adjusts treatments accordingly. Ayurvedic medicine similarly links seasonal cycles to human health and prescribes different foods, activities, and practices for different times of year. Even modern chronobiology, the scientific study of biological rhythms, confirms that humans have seasonal as well as daily cycles. Our immune systems function differently in different seasons. Our reproductive patterns show seasonal variations. Our cognitive performance varies with season and latitude. Our sleep patterns naturally shift with changing daylight hours. This scientific validation of seasonal human rhythms suggests that our disconnect from natural cycles may come with costs. Seasonal affective disorder affects millions of people in northern latitudes where winter brings dramatic reductions in daylight. But even beyond clinical conditions, many people report feeling out of sync with artificial schedules that ignore seasonal variations in energy and mood. Some forward-thinking workplaces and schools are beginning to recognize the importance of seasonal rhythms. Flexible schedules that allow for seasonal variations in start times, longer vacations during periods when energy is naturally lower, seasonal variations in work intensity. These approaches acknowledge that human productivity and well-being are naturally cyclical. On a larger scale, understanding seasonal rhythms may be crucial for addressing climate change and environmental degradation. Much of our environmental crisis stems from a linear, growth-oriented mindset that ignores natural cycles of growth and rest, abundance and scarcity. Learning to live seasonally might mean accepting that some periods are for growth and expansion, while others are for consolidation and rest, that abundance in one season should be saved for scarcity in another, that long-term sustainability requires working with natural cycles rather than against them. Indigenous cultures around the world maintain sophisticated seasonal knowledge that could inform modern approaches to sustainability. Their understanding of how to harvest without depleting, how to store abundance for scarcity, how to read environmental signals for optimal timing. This knowledge represents thousands of years of human experimentation with seasonal living. The seasonal perspective also offers a different approach to personal and social problems. Instead of expecting constant growth and improvement, seasonal thinking accepts that all systems go through cycles of expansion and contraction, activity and rest, creation and destruction. Problems that seem permanent from a linear perspective might be understood as seasonal challenges that will eventually pass and transform. In this view, difficult periods in life, whether personal struggles, economic recessions, or social upheavals, might be understood as winter seasons that serve important functions even as they challenge us. Just as winter allows trees to rest and consolidate their resources for spring growth, difficult periods might be necessary for reflection, reorganization, and preparation for new growth. Similarly, periods of abundance and success might be understood as summer seasons to be celebrated, but not expected to last forever. The seasonal perspective encourages us to enjoy good times while also preparing for inevitable changes, to store resources during abundance and share them during scarcity. This seasonal wisdom is particularly relevant as we face the challenges of the Anthropocene epoch. Human activities have begun to disrupt the seasonal patterns that have governed Earth's climate for millions of years. We are experiencing unprecedented changes in weather patterns, growing seasons, migration routes, and ecosystem dynamics. Many of the seasonal festivals and agricultural practices that sustained human cultures for millennia are becoming disconnected from the environmental realities they were designed to celebrate and coordinate. Yet understanding Earth's deep seasonal history also provides hope. Our planet has experienced dramatic climate changes before and has always found new equilibria. Life has survived ice ages, mass extinctions, and atmospheric transformations. The seasonal perspective suggests that our current climate crisis, while unprecedented in its speed and human causation, is still part of Earth's longer seasonal breathing. This doesn't minimize the urgency of addressing climate change, but it does suggest that solutions might be found by working with natural cycles rather than against them. Renewable energy systems that follow seasonal patterns of sun and wind, agricultural systems that mimic natural seasonal cycles, cities designed to breathe with seasonal variations rather than maintaining constant artificial conditions. The seasonal perspective also suggests that addressing climate change will require not just technological solutions but cultural ones, learning to live seasonally again, to accept cycles of abundance and scarcity, to plan for long-term changes, to celebrate the rhythms that connect us to the larger systems we depend on. As we face an uncertain climatic future, the seasonal festivals and traditions of our ancestors may provide not just historical curiosity, but practical wisdom. They represent humanity's accumulated knowledge about how to live in partnership with natural cycles, how to find meaning and community in the face of change, how to maintain hope during dark periods and humility during abundant ones. The story of how Earth breathes with the seasons is therefore not just a story about orbital mechanics and climate cycles, but about how life, including human life, learns to dance with cosmic rhythms. It's about finding our place in cycles larger than ourselves, about understanding that our individual lives are part of much larger patterns of breathing and renewal. Every season offers its own gifts and challenges. Spring brings renewal, but also the uncertainty of change. Summer brings abundance, but also the responsibility to use it wisely. Autumn brings harvest, but also the necessity of letting go. Winter brings rest, but also the patience to endure scarcity and wait for renewal. These seasonal gifts and challenges are available to us not just annually, but in every aspect of our lives. Every project, every relationship, every stage of life has its seasonal quality. Learning to recognize and honor these seasons, to plant when it's time to plant, to harvest when it's time to harvest, to rest when it's time to rest, may be one of the most important skills for living wisely on our tilted, breathing planet. And so, as our journey together draws toward its close like the sun settling toward the horizon at the end of a long day, let us take a moment to appreciate the profound gift of seasons. In a universe that could have been constant and unchanging, we find ourselves on a planet that breathes with regular rhythm, that offers us variety and renewal, that teaches us about cycles of growth and rest, abundance and scarcity, activity and contemplation. The tilt of our planet, which could have been seen as a cosmic accident, turns out to be the source of endless beauty and meaning. It gives us the changing colors of autumn leaves, the return of spring flowers, the long days of summer, the quiet contemplation of winter nights. It provides the rhythm around which life on Earth has organized itself for billions of years, the pattern that allowed complex ecosystems to develop, the stability that permitted human culture to flourish. Our seasonal nature connects us not just to our planet, but to the cosmos itself. The same orbital mechanics that give us seasons operate throughout the universe. Other planets have their own seasonal patterns. Mars with its dust storms and polar ice caps that expand and contract. Saturn with its hexagonal storms that change with its long seasonal cycle. The seasonal principle extends even to stars, which have their own life cycles of birth, maturity, and death, their own ways of breathing light and matter across space and time. Understanding how Earth breathes helps us understand our place in this cosmic symphony. We are not separate from the natural world, but embedded within it, our lives taking their rhythm from the same forces that move continents and steer ocean currents and guide the migration of birds across continents. Every breath we take contains atoms that have been breathed by countless other beings, cycled through the seasonal patterns of growth and decay that connect all life on Earth. This connection might inspire us to live with greater awareness of the seasonal rhythms that surround us, to notice how our own energy and mood cycle with the seasons, to appreciate the seasonal foods that connect us to local ecosystems, to participate in seasonal festivals and traditions that connect us to the wisdom of our ancestors and to communities around the world who still celebrate the turning of the year. It might also inspire us to think more seasonally about our problems and challenges. Instead of expecting constant growth and progress, we might learn to accept cycles of expansion and contraction, to plan for seasonal variations, to appreciate the gifts that each season brings. This seasonal wisdom could be applied to everything from personal relationships to economic planning to environmental policy. Most importantly, understanding how Earth breathes might help us find our place in the larger story of our planet and our universe. We are not accidental visitors to a lifeless rock, but seasonal creatures on a seasonal planet, participants in a cosmic dance that has been going on for billions of years and will continue for billions more. Every time we watch the sun set, every time we notice the first buds of spring or the first falling leaves of autumn, every time we celebrate a seasonal festival or simply feel our mood shift with changing light, we are participating in this dance. We are experiencing the same rhythms that guided our ancestors, that shape the behavior of animals and plants, that drive the great currents of ocean and atmosphere. In this participation lies both humility and wonder. Humility because it reminds us that we are not separate from nature, but part of it, subject to the same forces that govern all life on Earth. Wonder because it reveals that we live in a universe of pattern and meaning, where the motion of our planet around a distant star creates the rhythm that shapes everything from the smallest flower to the largest ecosystem. The breath of Earth is the breath of life itself. The in and out, the expansion and contraction, the activity and rest that characterizes all living systems. By learning to breathe with our planet, to align ourselves with its seasonal rhythms, we participate more fully in the community of life that has sustained itself on this tilted world for billions of years. And so tonight, as you prepare for sleep, you might pause to notice what season you find yourself in, both in the outer world and in the inner landscape of your own life. Are you in a season of planting new projects, of harvesting the fruits of past efforts, of rest and contemplation, of preparation for change? Each season has its own wisdom, its own gifts, its own necessary work. Tomorrow, the sun will rise, as it has every day for billions of years, and our tilted planet will continue its patient orbit, breathing in and out with the seasons, offering us once again the gift of change and renewal, the promise that winter will become spring, that dormancy will become growth, that even in the darkest nights, the light is already returning. This is the gentle breath of seasons made manifest in your own life, dear listener. Rest now, knowing that you are held by the same rhythms that have sustained life on this planet for billions of years, and will continue to sustain it for billions more. The ocean's seasonal heart. But the breath of seasons extends far beyond the land we walk upon. If you were to dive beneath the waves, you would discover that the oceans themselves breathe with the seasons in ways both magnificent and mysterious. The vast blue expanses that cover most of our planet are not uniform bodies of water, but dynamic systems that pulse and flow with seasonal rhythms that dwarf even the great migrations of birds or the turning of autumn leaves. In the polar regions, the seasonal breath of the ocean is most dramatic. As winter descends upon the Arctic, the sea begins to freeze, not all at once, but in a slow crystallization that spreads like a white web across the dark water. This ice formation is not merely a surface phenomenon, it creates one of the most important seasonal events in our planet's climate system. When seawater freezes, it leaves behind its salt, creating dense cold water that sinks toward the ocean floor. This sinking water begins a journey that will carry it around the entire globe, part of what oceanographers call the global thermohaline circulation, the ocean's great seasonal breathing system. The cold, dense water formed in polar winters sinks and flows along the ocean floor toward the equator, while warmer surface water flows poleward to replace it. This oceanic breathing operates on multiple timescales simultaneously. There is the annual pulse of ice formation and melting, the seasonal warming and cooling of surface waters, and the much slower circulation of deep waters that takes centuries to complete a full cycle. A molecule of water that sinks in the Arctic Ocean during this winter might not return to the surface for several hundred years, having traveled through the deep Atlantic, around the southern tip of Africa, across the Indian Ocean, and through the Pacific before finally rising again in some distant sea. The seasonal formation and melting of sea ice creates habitats that exist nowhere else on Earth. As the ice forms, it traps pockets of concentrated seawater, brine channels that become home to specialized communities of algae, bacteria, and tiny animals that have adapted to life in this frozen matrix. These ice communities form the base of Arctic food webs, supporting everything from tiny zooplankton to massive walruses and polar bears. When spring arrives in the polar regions, the melting ice releases these concentrated nutrients into the water, triggering some of the most spectacular blooms of life on Earth. Arctic and Antarctic waters, so barren-looking in winter, explode with phytoplankton blooms so massive they can be seen from space, green and blue swirls that stretch for hundreds of miles, the ocean's equivalent of spring flowers carpeting a meadow. These polar blooms support vast populations of krill, tiny shrimp-like creatures that form the cornerstone of polar marine ecosystems. The seasonal abundance of krill draws millions of seabirds, seals, and whales to polar waters during the brief summer months. Blue whales, the largest animals ever to exist on Earth, time their migrations to arrive just as krill populations reach their peak, gorging themselves on these tiny creatures to sustain them through the rest of the year. But the ocean's seasonal breathing is not limited to polar regions. In temperate waters, spring brings its own underwater awakening. As surface waters warm and days grow longer, microscopic plants called phytoplankton begin their annual bloom. These tiny organisms, invisible to the naked eye, but numbering in the trillions, form the foundation of marine food webs and produce much of the oxygen we breathe. The timing of these spring blooms is crucial for countless marine species. Fish, squid, and marine mammals have evolved to time their reproduction to coincide with peak plankton abundance. Herrings spawn in vast numbers just as their zooplankton prey begins to flourish. Cod migrate hundreds of miles to reach spawning grounds where their larvae will hatch into waters rich with food. Even the great whales coordinate their breeding cycles with seasonal plankton blooms, ensuring their calves are born when food will be most abundant. The seasonal cycles of marine productivity create some of the most important fishing grounds on Earth. The Grand Banks off Newfoundland, the Humboldt Current off Peru, the Benguela Current off southern Africa, all of these regions are productive because of seasonal upwelling patterns that bring nutrient-rich deep water to the surface, fertilizing the sea and supporting enormous populations of fish. These upwelling systems are driven by seasonal wind patterns that change with the movement of high and low pressure systems across the ocean basins. When winds blow consistently from one direction, they push surface water away from coastlines, allowing deep, cold, nutrient-rich water to rise and replace it. This upwelling water is like liquid fertilizer for the sea, carrying nutrients from the deep ocean floor back to the sunlit surface waters where photosynthesis can occur. The California Current system provides a perfect example of seasonal upwelling. During spring and summer, persistent northwesterly winds drive surface water offshore, creating upwelling along the entire west coast of North America. This cold, nutrient-rich water supports some of the most productive marine ecosystems in the world, from the kelp forests of California to the salmon runs of Alaska. When autumn arrives and the wind patterns shift, the upwelling weakens and surface waters warm. This seasonal change affects everything from the microscopic plankton to the great whales that feed on them. Seabirds that nested in massive colonies during the productive summer months disperse across the ocean in search of food. Fish populations shift their distributions, and the entire character of the marine ecosystem transforms. But perhaps the most dramatic example of seasonal oceanic breathing occurs in the tropics, where monsoon systems create seasonal reversals in ocean circulation. In the Indian Ocean, the seasonal monsoon winds actually reverse the direction of major currents twice each year. During the northeast monsoon, surface waters flow westward across the ocean basin. During the southwest monsoon, they reverse and flow eastward. This seasonal breathing of the tropical ocean affects weather patterns across half the planet and supports billions of people whose lives depend on monsoon rains. The monsoon cycle demonstrates how intimately connected the ocean and atmosphere are in their seasonal breathing. The monsoons are driven by seasonal heating and cooling of large landmasses, which creates pressure differences that drive wind patterns, which in turn drive ocean currents, which affect the distribution of heat and moisture in the atmosphere, which influences rainfall patterns across entire continents. This connection between oceanic and atmospheric breathing becomes even more complex when we consider how marine ecosystems respond to and influence these large-scale patterns. Phytoplankton blooms don't just respond to seasonal changes in ocean conditions, they help create them. These microscopic plants remove carbon dioxide from the atmosphere during photosynthesis, affecting global climate patterns. When they die and sink to the deep ocean, they carry carbon with them, helping to regulate the planet's carbon cycle. The seasonal timing of these biological processes has profound implications for global climate. The spring bloom of phytoplankton in northern oceans removes enormous quantities of carbon dioxide from the atmosphere, just as spring warming might otherwise cause atmospheric carbon levels to rise. The autumn die-off and sinking of marine organisms transports this carbon to the deep ocean, where it may remain for centuries or millennia. Some marine organisms have evolved to take advantage of specific seasonal conditions in ways that seem almost magical. The Grunion fish of Southern California time, their spawning to coincide with the highest spring tides, which occur during full and new moons. These small fish ride the waves onto sandy beaches, spawn in the sand, and return to sea with the next wave. Their eggs develop in the warm sand for exactly 2 weeks, hatching just in time for the next cycle of extreme tides to wash the larvae back into the ocean. Even more remarkable is the seasonal vertical migration that occurs in the open ocean every single day. As the sun sets, billions of marine animals rise from the depths toward the surface to feed on phytoplankton and smaller zooplankton. This daily migration is so massive that early sonar operators mistook the migrating animals for the sea floor itself, a false bottom that rose and fell with mysterious regularity. This daily vertical migration is actually seasonal as well, varying in intensity and timing, with the changing length of days and the seasonal abundance of food. During the long days of summer, the migration begins later and ends earlier, as animals take advantage of extended feeding opportunities. During winter's short days, the migration patterns shift, with animals spending more time in surface waters to maximize their feeding time. The seasonal breathing of the ocean also creates temporary habitats that exist only at specific times of year. During spring snowmelt, rivers carry massive loads of fresh water into the sea, creating temporary layers of less dense water that float on top of the saltier ocean water. These ephemeral environments support unique communities of organisms adapted to the changing salinity and temperature conditions. River plumes during flood seasons can extend hundreds of miles into the ocean, carrying nutrients and sediments that fertilize marine ecosystems far from shore. The Amazon River plume, visible from space during the wet season, creates a moving habitat that supports unique assemblages of marine life as it spreads across the tropical Atlantic. Even the deep ocean, seemingly isolated from seasonal changes at the surface, breathes with seasonal rhythms. Deep-sea organisms have evolved to detect and respond to the seasonal rain of organic matter that sinks from surface waters. When spring blooms occur thousands of feet above, deep-sea animals prepare for the seasonal bounty that will eventually reach them. Some deep-sea species time their reproduction to coincide with these seasonal food pulses, even though they live in perpetual darkness and may never directly experience seasonal temperature changes. The seasonal breathing of the ocean reminds us that the boundaries we perceive between ocean and atmosphere, between land and sea, between surface and depth, are largely artificial. The ocean is not separate from the seasonal system, but an integral part of it, breathing in rhythm with the atmosphere, responding to the same solar cycles, participating in the same great dance of energy and matter that connects all parts of our planet. Understanding the ocean's seasonal rhythms helps us appreciate the true complexity of Earth's breathing system. It's not just the land that inhales and exhales with the seasons, but the sea as well, in patterns that operate from the surface to the deepest trenches, from daily cycles to currents that take centuries to complete their circuits. This oceanic breathing affects every aspect of our planet's climate and life. The fish we eat, the weather we experience, the oxygen we breathe, the stability of our climate, all of these depend on the seasonal rhythms of the sea. To understand how Earth breathes, we must understand not just the terrestrial cycles of growth and dormancy, but the marine cycles of productivity and circulation that connect every part of our blue planet in one vast breathing system. The atmosphere's seasonal dance, Above the breathing land and the pulsing sea, the atmosphere itself dances with the seasons in patterns that span from the ground beneath our feet to the edge of space itself. If the seasons teach us anything, it is that our planet is not a collection of separate systems, but one integrated organism breathing through multiple interconnected layers. The most obvious seasonal breathing of the atmosphere is the one we experience daily, the changing weather patterns that follow the sun's annual journey across the sky. But this surface breathing is just the beginning of a complex atmospheric symphony that extends upward through layers most of us never think about, each one breathing with its own seasonal rhythm. In the troposphere, the layer where weather occurs and where we live, seasonal breathing manifests in the great circulation patterns that move heat and moisture around the globe. During Northern Hemisphere summer, the intertropical convergence zone, where air masses from the northern and southern hemispheres meet, shifts northward, bringing monsoon rains to regions that would otherwise be desert. During northern winter, this zone of converging air masses shifts southward, reversing weather patterns across tropical regions. These seasonal shifts in atmospheric circulation create some of the most dramatic weather patterns on Earth. The Asian monsoon system, which affects the lives of over 1 billion people, is essentially the atmosphere's seasonal breathing made manifest as wind and rain. During summer, intense heating of the Asian landmass creates a massive low-pressure system that draws moisture-laden air from the Indian Ocean inland, bringing the rains that sustain agriculture across much of Asia. During winter, the circulation reverses, and dry air flows from the continental interior back toward the ocean. This monsoon breathing is so powerful that it actually affects the rotation speed of the Earth itself. When billions of tons of air shift from oceanic to continental circulation patterns, the redistribution of mass is enough to minutely alter our planet's rotation rate. The Earth breathes not just biologically and chemically, but physically, its very spin subtly affected by the seasonal movement of its atmosphere. Higher in the atmosphere, in the stratosphere, seasonal breathing takes on different characteristics. Here, about 20 to 30 miles above Earth's surface, lies the ozone layer, a thin shell of gas that protects life on the surface from harmful ultraviolet radiation. The ozone layer itself breathes seasonally, thickening and thinning in response to changing solar radiation and atmospheric circulation patterns. During polar winter, when the sun disappears for months at a time, chemical processes in the stratosphere create conditions that can lead to dramatic ozone depletion. The infamous ozone hole over Antarctica forms each southern hemisphere spring as a result of these seasonal processes. Chlorine compounds that accumulate during the dark polar winter destroy ozone when the sun returns in spring, creating a seasonal wound in Earth's protective atmospheric layer. This stratospheric breathing affects more than just ozone chemistry. The seasonal heating and cooling of the stratosphere drives circulation patterns that influence weather in the troposphere below. The polar vortex, a ring of strong winds that normally keeps cold air trapped around the Arctic, can weaken during certain seasonal conditions, allowing frigid air to spill southward and bring extreme cold to temperate regions. Even higher, in the mesosphere and thermosphere, the atmosphere continues to breathe seasonally. Here, 50 to 400 miles above the surface, the thin air is directly heated by solar radiation and responds dramatically to seasonal changes in the sun's angle and intensity. During summer, these upper atmospheric layers can be hundreds of degrees warmer than during winter, causing them to expand and contract with the seasons like a vast atmospheric lung. This seasonal expansion and contraction of the upper atmosphere has practical consequences for human technology. Satellites in low Earth orbit experience more atmospheric drag during solar maximum and summer conditions when the atmosphere is expanded, causing their orbits to decay more rapidly. Space agencies must account for these seasonal atmospheric rhythms when planning satellite missions and orbital mechanics. The seasonal breathing of the atmosphere also creates spectacular visual phenomena that have inspired humans throughout history. The aurora borealis and aurora australis, the northern and southern lights, are strongest during equinox seasons, when Earth's magnetic field is optimally oriented to channel solar wind particles into the upper atmosphere. These seasonal light shows are the atmosphere's way of breathing solar energy, converting it into visible light through interactions with atmospheric gases. Noctilucent clouds, rare silver-blue formations that appear in the highest reaches of the atmosphere, also follow seasonal patterns. These ethereal clouds, visible only during summer twilight at high latitudes, form when water vapor reaches the cold mesosphere and condenses on tiny particles. They are the atmosphere's most delicate seasonal breath, visible only when conditions are perfectly aligned. The atmosphere's seasonal breathing also drives the formation and movement of the great wind belts that encircle our planet. The trade winds, westerlies, and polar easterlies all shift position seasonally as pressure systems move north and south following the sun. These shifting wind patterns affect everything from ocean currents to bird migration routes to the spread of seeds and spores across the globe. Even the jet streams, narrow bands of fast-moving air in the upper troposphere, breathe seasonally. During winter, temperature differences between polar and tropical regions are greatest, creating strong, stable jet streams that flow in relatively straight paths around the globe. During summer, these temperature differences weaken, causing jet streams to become more variable and wavy, creating the blocking patterns that can lead to heat waves, droughts, and persistent weather patterns. The seasonal breathing of atmospheric moisture creates some of Earth's most important climate patterns. The Walker circulation across the Pacific Ocean, which drives normal weather patterns from Australia to South America, strengthens and weakens seasonally. When this circulation is disrupted, it can lead to El Niño and La Niña events that affect weather patterns worldwide. These Pacific circulation patterns demonstrate how the atmosphere's seasonal breathing operates on multiple timescales simultaneously. There is the annual cycle of monsoons and seasonal wind shifts, the several-year cycle of El Niño and La Niña, and even longer cycles like the Pacific Decadal Oscillation that influence weather patterns for decades at a time. The atmosphere also breathes chemically, with seasonal changes in the concentration of various gases. Carbon dioxide levels in the atmosphere rise and fall seasonally as northern hemisphere vegetation alternately absorbs CO2 during summer growing seasons and releases it during winter dormancy. This seasonal breathing of the global forest is so pronounced that it can be measured at monitoring stations around the world, creating a yearly sawtooth pattern in atmospheric CO2 concentrations. Water vapor, the atmosphere's most variable greenhouse gas, also breathes seasonally. Summer brings higher humidity to many regions, as increased evaporation from warm surfaces adds moisture to the air. Winter's cold air holds less moisture, creating the dry conditions that contribute to increased heating costs and chapped lips. This seasonal breathing of atmospheric water vapor affects not just comfort levels, but also the rate of weathering of rocks, the health of ecosystems, and the intensity of storms. Dust and aerosols in the atmosphere follow seasonal patterns as well. Spring brings dust storms as winter vegetation dies back and summer winds pick up loose soil. Autumn brings smoke from agricultural burning and natural wildfires. Even pollen follows seasonal atmospheric patterns, with different species contributing to the atmospheric load at different times of year, creating the seasonal allergy cycles that affect millions of people. The seasonal breathing of the atmosphere connects directly to human health and well-being in ways we're only beginning to understand. Seasonal affective disorder is the most obvious example, but research is revealing that atmospheric pressure changes, humidity cycles, and even the concentration of negative ions in the air vary seasonally and can affect human mood, sleep patterns, and cognitive performance. Traditional weather lore and folk wisdom often recognized these subtle atmospheric rhythms. Farmers learned to read cloud patterns and wind directions to predict seasonal weather changes. Sailors developed sophisticated understanding of seasonal wind patterns and storm cycles. Even urban dwellers learned to anticipate seasonal changes in air quality and atmospheric conditions. Modern meteorology has revealed the scientific basis for much of this traditional knowledge, showing that the atmosphere's seasonal breathing follows predictable patterns that can be measured and forecast. Weather prediction models now incorporate seasonal forecasting, attempting to predict not just tomorrow's weather but the general character of entire seasons months in advance. Understanding the atmosphere's seasonal breathing is crucial for addressing contemporary challenges like climate change and air pollution. As global temperatures rise, seasonal patterns are shifting, with longer summers, shorter winters, and changes in precipitation patterns that affect everything from agriculture to water supplies to extreme weather events. The atmosphere's response to climate change is itself seasonal, with warming occurring faster in winter than summer, and faster in polar regions than tropical ones. These differential seasonal responses are changing the very patterns of atmospheric circulation that have shaped weather patterns for millennia, creating new seasonal rhythms that life on Earth must adapt to. Yet even as we alter the atmosphere's seasonal breathing through our emissions of greenhouse gases and other pollutants, the fundamental drivers of atmospheric seasonality remain unchanged. The tilt of Earth's axis still creates the seasonal cycle of solar heating that drives atmospheric circulation. The rotation of the planet still creates the Coriolis effect that shapes wind patterns. The basic physics of atmospheric motion still operates according to the same principles that have governed weather for billions of years. This suggests that while we may be changing the intensity and timing of atmospheric seasonal patterns, we are not eliminating seasonality itself. The atmosphere will continue to breathe seasonally, but perhaps with different rhythms, different intensities, and different geographical patterns than those that shaped the evolution of life on Earth. Understanding these changing atmospheric rhythms may be crucial for adapting to our planet's altered seasonal breathing. By learning to read the new patterns, by understanding how atmospheric circulation is shifting, by recognizing that seasonal weather patterns are themselves evolving, we may be better able to work with rather than against the atmosphere's changing seasonal breath. The atmosphere reminds us that seasonal breathing is not just a biological phenomenon, but a physical and chemical one as well. The same seasonal cycles that cause trees to bud and birds to migrate also drive massive movements of air and water around the globe, create and destroy chemical compounds in the stratosphere, and generate the electrical phenomena we see as lightning and aurora. To truly understand how Earth breathes, we must appreciate that seasonal breathing occurs simultaneously across all these scales and systems, from the microscopic seasonal cycles of atmospheric chemistry to the planetary scale circulation patterns that connect Arctic ice with tropical rainforests. The atmosphere is not just the medium through which seasons occur, but an active participant in seasonal breathing, inhaling and exhaling energy and matter in patterns that help regulate the entire planet's climate system. The underground seasons, beneath our feet, hidden from the cycling light that drives surface seasons, lies a world that breathes with its own seasonal rhythms. This underground realm, from shallow soil layers to deep groundwater systems, participates in Earth's seasonal breathing in ways both subtle and profound, creating patterns of life and activity that most surface dwellers never suspect. The soil itself is perhaps the most active seasonal breathing system on our planet. What appears to be lifeless dirt is actually a complex ecosystem containing more organisms than exist above ground. A single handful of healthy soil contains billions of bacteria, millions of fungi, thousands of protozoa, and hundreds of nematodes, all participating in intricate seasonal cycles of activity and dormancy. As autumn progresses and leaves fall, This underground world prepares for its own seasonal transformation. Fallen leaves, dead roots, and other organic matter become the fuel for an underground fire of decomposition that will burn slowly throughout the winter. Soil organisms work in shifts, each group specialized for different stages of decay, different temperature ranges, different moisture conditions. During winter, when surface activity slows or stops entirely, the soil continues to breathe. Bacterial populations shift as cold-adapted species take over from their warm-weather relatives. Fungal networks, which can remain active even in freezing soil, continue to break down organic matter and transport nutrients between distant plants. Some soil organisms enter dormant stages, forming spores or cysts that will wait months for favorable conditions to return. The seasonal breathing of soil is literally measurable. Scientists use sensitive instruments to detect the carbon dioxide that healthy soil exhales as microorganisms respire. This soil respiration follows predictable seasonal patterns, increasing with temperature and moisture, peaking during warm, humid periods when decomposition is most active, and slowing during cold or dry seasons. But soil breathing involves more than just carbon dioxide. Healthy soil inhales oxygen for the countless organisms living within it, exhales methane and other trace gases produced by anaerobic processes, and cycles nitrogen, sulfur, phosphorus, and dozens of other essential elements through complex seasonal patterns. Different soil layers breathe at different rates and with different timing, creating a vertical gradient of seasonal activity that extends from the surface down to the bedrock. Root systems create their own seasonal underground networks that connect individual plants into vast breathing communities. During growing seasons, roots actively exchange gases, nutrients, and even chemical messages with their neighbors through soil networks mediated by fungi. These mycorrhizal networks can extend for miles underground, connecting forests, grasslands, and even individual garden plants in chemical communication networks that pulse with seasonal activity. In autumn, as above-ground plants prepare for dormancy, their roots often become more active, storing energy and nutrients for winter survival and spring growth. Sugar maples pump sugars from their leaves into their roots before dropping their foliage. Prairie grasses shift their focus from above-ground growth to root expansion, sometimes adding several feet of new root growth even as their surface portions die back. These seasonal root activities create underground storms of chemical activity. Acids secreted by roots help dissolve minerals from rock and soil particles. Hormones and other signaling molecules coordinate the timing of dormancy and growth among connected plants. Defensive compounds produced by some roots protect entire plant communities from soil-borne pathogens and pests. The seasonal cycles of underground plant activity drive corresponding cycles in soil organisms. Bacteria that specialize in processing root exudates flourish during active growing seasons. Fungi that form partnerships with plant roots synchronize their reproductive cycles with their host plant's seasonal rhythms. Even soil-dwelling insects and other larger creatures time their life cycles to take advantage of seasonal pulses of root activity. Groundwater systems, flowing through underground channels and aquifers, sometimes hundreds of feet below the surface, also participate in seasonal breathing patterns. Spring snowmelt and seasonal rains recharge aquifers, raising water tables and increasing the flow of underground streams. During dry seasons, groundwater levels drop, concentrating dissolved minerals and changing the chemistry of underground water systems. These seasonal fluctuations in groundwater affect everything from well water quality to the health of wetlands that depend on underground water supplies. Rivers that appear to flow year-round may actually be sustained by groundwater discharge during dry seasons, while the same aquifers are recharged by river water during flood periods. This seasonal breathing between surface and groundwater creates the base flow that keeps rivers running and wetlands wet during drought periods. Cave systems represent some of the most stable underground environments, yet even they breathe seasonally. Air circulation in caves responds to seasonal temperature differences between surface and underground environments. During winter, warm cave air rises out of cave entrances, drawing cold surface air down through other openings. During summer, the circulation may reverse as cool cave air sinks, while warmer surface air is drawn into the cave system. These seasonal air movements in caves affect the underground organisms that live in these stable environments. Bats that hibernate in caves rely on seasonal air circulation to maintain the precise temperature and humidity conditions they need for successful hibernation. Cave-adapted insects and other invertebrates may time their reproductive cycles to seasonal changes in air circulation and the availability of organic matter washed into caves by seasonal floods. The underground world also includes vast networks of artificial spaces that breathe seasonally. Urban subway systems, utility tunnels, and building foundations create underground environments that experience their own seasonal cycles. Steam from heating systems in winter, increased groundwater infiltration during spring thaws, and temperature fluctuations transmitted through building structures all contribute to underground seasonal patterns in cities. Even deeper underground, in mines and deep aquifers, seasonal breathing continues. Changes in atmospheric pressure at the surface are transmitted through rock and soil, creating seasonal variations in deep underground air and water pressure. Geothermal systems may show subtle seasonal variations as surface temperature changes affect the shallow portions of underground heat systems. Mining operations have long recognized seasonal patterns in underground conditions. Cave-ins and gas emissions often follow seasonal patterns related to groundwater fluctuations and temperature changes transmitted from the surface. Even abandoned mines continue to breathe seasonally, with air circulation patterns that change with surface weather and seasonal temperature variations. The seasonal breathing of underground systems creates opportunities for specialized forms of life that exist nowhere else. Certain bacteria thrive in the seasonal temperature and moisture fluctuations of shallow groundwater. Specialized fungi fruit only during specific seasonal conditions when soil temperature and moisture reach optimal combinations. Root parasitic plants time their emergence to coincide with seasonal peaks in host plant root activity. Some underground organisms have evolved to exploit seasonal movements between surface and underground environments. Earthworms migrate vertically through soil layers seasonally, moving deeper during dry or frozen periods and returning to surface layers when conditions improve. Ground-dwelling beetles and other insects follow similar seasonal migration patterns, using underground refugia during harsh surface conditions. The seasonal breathing of underground systems also affects human activities in ways we rarely consider. Foundation settling and frost heaving follow seasonal patterns of soil freezing and thawing. Septic systems and drainage fields function differently in different seasons as soil conditions change. Even underground cables and pipes are affected by seasonal soil movements and groundwater fluctuations. Agricultural systems depend heavily on the seasonal breathing of soil and underground root networks. Farmers time their planting and cultivation activities to work with rather than against seasonal soil conditions. Soil temperature, moisture, and biological activity must all be considered when deciding when to plant, when to fertilize, and when to harvest crops. Understanding underground seasonal patterns is becoming increasingly important as we face challenges related to groundwater depletion, soil degradation, and climate change. As surface temperatures rise and precipitation patterns shift, underground systems must adapt to new seasonal rhythms. Deeper drought may affect groundwater recharge patterns. Changed precipitation timing may alter soil seasonal cycles. Rising temperatures may shift the seasonal activity patterns of soil organisms. Yet the underground world also offers resilience and stability that surface systems often lack. Soil and groundwater systems change more slowly than surface environments, providing buffering against rapid climate changes. Deep root systems and soil organic matter can store carbon and nutrients, helping to moderate the effects of surface environmental changes. The seasonal breathing of underground systems reminds us that Earth's seasonal rhythms penetrate every part of our planet's living systems. From the shallow soil where earthworms migrate seasonally to the deep aquifers that store winter's snow for summer's use, the underground world participates fully in the great seasonal symphony that connects all life on Earth. Understanding this underground seasonal breathing helps us appreciate the true complexity and interconnectedness of Earth's systems. The roots beneath our feet are not just anchors for individual plants, but participants in vast underground networks that breathe seasonally, exchanging nutrients, water, gases, and even information in patterns that help coordinate the seasonal activities of entire ecosystems. To walk across the land during any season is to walk above a hidden world that is breathing, working, and preparing in its own seasonal rhythms. Every step we take is supported not just by solid ground, but by living soil, breathing with its billions of organisms in patterns that connect the fallen leaves of last autumn to the emerging shoots of next spring. Human bodies and seasonal rhythms. Within our own bodies, the ancient seasonal breathing of Earth continues to influence us in ways both profound and subtle. Despite our heated homes, electric lights, and global food systems, we remain creatures shaped by millions of years of evolution under the influence of seasonal cycles. Our bodies carry the memory of countless generations who survived by attuning themselves to the rhythms of the tilted planet. The most obvious seasonal breathing in human physiology occurs in our circadian rhythms, the internal clocks that govern our daily cycles of sleep and wakefulness. These clocks are not fixed but adjust themselves seasonally in response to changing daylight patterns. During long summer days, our bodies naturally want to stay awake later and wake up earlier, matching the extended period of available light. During short winter days, we tend toward longer sleep periods and may struggle with the energy and mood changes that come with reduced light exposure. This seasonal adjustment of our sleep-wake cycles is controlled by the pineal gland, a tiny structure deep in the brain that produces the hormone melatonin in response to darkness. As days grow shorter in autumn and winter, melatonin production increases, encouraging longer sleep periods and the contemplative, inward-turning mood that many cultures associate with the dark months of the year. But seasonal breathing in human physiology extends far beyond sleep patterns. Our immune systems show pronounced seasonal variations, with different components becoming more or less active depending on the time of year. During autumn and winter, when respiratory infections are most common, certain immune responses become more aggressive, while during summer months, when UV radiation and heat stress are greater challenges, other immune mechanisms take precedence. This seasonal immune breathing may explain why we are more susceptible to certain illnesses at particular times of year. The common cold and flu peak during winter months, not just because we spend more time indoors in close contact with others, but because seasonal changes in our immune systems create windows of vulnerability that viruses have evolved to exploit. Our cardiovascular systems also breathe seasonally. Blood pressure tends to be higher during winter months and lower during summer, a pattern that may reflect seasonal changes in physical activity, diet, light exposure, and stress levels. Heart attack rates show seasonal patterns as well, with peaks often occurring during the stress and dietary changes of holiday seasons, and also during the physical demands of activities like snow shoveling. Even our reproductive systems follow seasonal rhythms that echo the patterns of our ancient ancestors. Birth rates in many populations show seasonal peaks that suggest conception rates are higher at certain times of year. Testosterone levels in men fluctuate seasonally, typically peaking in autumn. Women's menstrual cycles may be influenced by seasonal changes in light exposure and may shift slightly with changing seasons. The seasonal breathing of human metabolism is perhaps most noticeable in our changing appetites and cravings throughout the year. Many people find themselves drawn to heartier, higher-calorie foods as autumn progresses into winter, a tendency that may reflect an ancient adaptation for building energy reserves before the scarce months of late winter and early spring. Our bodies may be responding to seasonal light cues by preparing for a famine that no longer comes in our food-abundant modern world. This seasonal metabolic breathing also affects our body weight and composition. Many people gain weight during winter months and lose it during summer, following a pattern that may once have been crucial for survival. The infamous winter weight gain and summer beach body cycle may be less about holiday indulgence and more about deep physiological rhythms that evolved over millions of years. Our mental and emotional states show some of the most dramatic seasonal breathing patterns. Seasonal affective disorder represents an extreme example, but even people who don't meet clinical criteria for SAD often notice seasonal changes in mood, energy, creativity, and cognitive function. The contemplative, inward-turning tendencies of winter contrast with the active, social, outward-focused energy that many people experience during longer days of spring and summer. These seasonal mood patterns may reflect evolutionary adaptations to different seasonal challenges and opportunities. Winter's introspective tendencies might have encouraged the planning, tool-making, and social bonding activities that helped our ancestors survive harsh conditions. Summer's active, exploratory moods might have supported the foraging, traveling, and relationship-building activities that were most beneficial during seasons of abundance. Research in chronobiology, the science of biological rhythms, reveals that virtually every physiological system in the human body shows some degree of seasonal variation. Hormone levels, neurotransmitter production, enzyme activity, cellular repair mechanisms, and even gene expression all fluctuate with seasonal patterns that reflect our evolutionary heritage as creatures of a seasonally variable world. Some of these seasonal physiological changes can be quite pronounced. Vitamin D levels, produced when skin is exposed to sunlight, naturally drop during winter months in temperate and polar regions, affecting not just bone health but also immune function, mood regulation, and cognitive performance. The seasonal decline in vitamin D may be one factor contributing to winter depression, increased illness susceptibility, and the reduced energy levels that many people experience during dark months. Cortisol, often called the stress hormone, also shows seasonal patterns, typically being higher during winter months when environmental challenges are greatest. This seasonal stress response may have been adaptive for our ancestors, helping them maintain alertness and energy during periods when food was scarce and weather was harsh. But in our modern world, chronically elevated winter cortisol levels may contribute to seasonal depression and other health problems. Even our sensory systems breathe seasonally. Our pupils tend to be larger during winter months, possibly an adaptation for gathering maximum light during periods of reduced illumination. Our sense of smell may be more acute during certain seasons, perhaps reflecting seasonal differences in the importance of detecting food sources, predators, or other environmental cues. Children's growth patterns show seasonal variation, with many experiencing growth spurts during spring and summer months. This seasonal growth breathing may reflect the interaction of multiple factors including nutrition, physical activity, sunlight exposure, and hormonal cycles. The timing of puberty itself can be influenced by seasonal factors, particularly light exposure and nutrition. Traditional cultures around the world developed sophisticated understanding of these seasonal human rhythms. Traditional Chinese medicine recognizes that different organ systems are most active during different seasons and adjusts treatments accordingly. Ayurvedic medicine similarly prescribes different foods, activities, and treatments for different seasons based on the understanding that human physiology changes with natural cycles. Many traditional cultures also developed seasonal dietary practices that supported optimal health throughout the year. These weren't just based on what was available, but on careful observation of how different foods affected energy, mood, and well-being during various phases of the seasonal cycle. In agrarian societies, spring often brought cleansing or fasting rituals designed to shed the heaviness of winter. Bitter greens, sprouts, and light soups were consumed to wake up the body after months of preserved or heavy foods. Summer diets emphasized fresh fruits and vegetables, cooling grains, and plenty of hydration, supporting the higher metabolic rate and outdoor activity of the season. Autumn meals turned grounding and restorative, featuring root vegetables, grains, and warming spices that prepared the body for the colder months ahead. Winter diets favored stews, fermented foods, and nutrient-dense animal products to maintain warmth and strength. In modern times, with global trade making nearly every type of food available year-round, we often ignore these cycles, eating strawberries in January and heavy stews in July. While this offers convenience and choice, it may also confuse the subtle biological rhythms that still expect seasonal signals. Emerging research in nutrigenomics suggests that our genes are not static, but respond dynamically to environmental cues, including food availability and light exposure. Eating seasonally, even when not strictly necessary for survival, might therefore help align our bodies with their natural programming, improving digestion, immune function, and mental health. Our seasonal connection extends beyond biology into behavior, social organization, and even culture itself. Anthropologists note that human rituals, festivals, and religious calendars are often aligned with solstices, equinoxes, planting and harvest cycles, or celestial events that mark seasonal transitions. These gatherings likely served more than spiritual or social functions. They helped synchronize group behavior with natural cycles, ensuring cooperation in hunting, planting, harvesting, and preparing for winter. Modern holidays like New Year's, Easter, and Thanksgiving still carry echoes of these ancient seasonal observances, even if their original ecological context is forgotten. Psychologists studying seasonal patterns of creativity and problem-solving find that winter months often foster reflective, long-term thinking, while spring and summer promote divergent thinking and innovation. This might explain why some of history's great philosophical, mathematical, and literary works were written during periods of seasonal isolation or in latitudes with long contemplative winters. Conversely, revolutions, migrations, and artistic renaissances often ignite during times of year associated with renewal and collective activity. Urban living, artificial light, and climate control have muted many of these natural rhythms, but not erased them. People living in cities still experience seasonal shifts in mood, metabolism, and social activity, though these shifts may manifest more subtly. The rise of seasonal reset movements, winter wellness retreats, spring detoxes, autumn harvest festivals, suggests a growing desire to re-establish harmony with nature's timing. Biohackers and wellness enthusiasts are even experimenting with light therapy, cold exposure, and seasonal eating protocols to deliberately re-entrain their physiology to ancient cycles. Modern chronobiology is beginning to validate what traditional cultures have long intuited, that living in sync with the seasons may prevent disease and promote well-being. For example, exposure to morning light in winter can help stabilize circadian rhythms, reducing seasonal depression and improving sleep quality. Strategic use of cold exposure, such as winter swimming or cold showers, may stimulate brown fat activity, boost metabolism, and improve immune resilience. Seasonal variations in exercise type and intensity may also be beneficial. Strength training during winter to maintain muscle mass, endurance training in spring and autumn, and lighter, cooling exercise in summer to prevent overheating and stress on the cardiovascular system. Spiritual traditions have also framed seasonal cycles as metaphors for inner growth. The death of winter becomes a time for introspection, shadow work, and letting go. The rebirth of spring represents new beginnings, planting intentions and creative emergence. Summer embodies fullness, connection, and celebration, while autumn invites reflection, gratitude, and preparation for the inward journey ahead. In this way, the body's seasonal breathing becomes a map for the soul's development, a rhythm of dying and rebirth that repeats not only each year, but across the arc of a lifetime. Even technology may soon help us restore lost seasonal connections. Wearable devices already track sleep, heart rate variability, and light exposure, offering data that could be used to optimize seasonal health routines. Imagine an app that not only tells you when to wake and sleep, but also recommends seasonal foods, suggests optimal exercise types, and reminds you of upcoming solstices and equinoxes, so you can align your activities with planetary rhythms. Far from alienating us from nature, technology could guide us back toward a deeper synchrony with it, if we choose to use it wisely. There is also a growing recognition in medicine that treatments might work differently depending on the season. Researchers are studying chronotherapy, in which medications are timed not just to circadian rhythms but also to seasonal ones. Some antidepressants may be more effective when started in autumn, anticipating the winter decline in serotonin. Certain vaccines may work better when administered at specific times of year, when immune responsiveness is naturally heightened. Even cancer treatments may benefit from timing with the body's seasonal fluctuations in cell growth and immune surveillance. Children, in particular, may benefit from restoring seasonal connections. Outdoor play in winter, despite the chill, has been shown to boost immune function, improve sleep, and reduce hyperactivity. Seasonal school rhythms, with breaks that allow for rest, exploration, and exposure to changing natural conditions, may better support cognitive development than year-round uniform schedules. As digital devices increasingly draw children indoors, educators and parents face the challenge of preserving these essential seasonal experiences. At a societal level, acknowledging seasonal rhythms might even shape public health policy. Urban design could prioritize natural light exposure in public buildings, parks, and schools. Workplaces could experiment with seasonally adjusted schedules, allowing more rest during dark months and extended activity during light-filled summer days. Such measures could reduce burnout, improve productivity, and align human systems more closely with the Earth's natural breathing. Ultimately, remembering that we are seasonal beings may bring a sense of belonging in a time when many feel disconnected from nature. The cycles of growth and rest, light and dark, activity and stillness are not merely external events. They are inscribed in our very cells. By learning to listen again to this deep inner tide, we may find not only better health but also a renewed sense of meaning and harmony with the world. The Earth will continue its patient, rhythmic turning whether or not we pay attention. But when we attune ourselves to its breath, through food, light, movement, ritual, and reflection, we rediscover something profound: that we are not separate from the living world, but part of its grand choreography. To breathe with the seasons is to live more fully, more wisely, and perhaps even more joyfully, honoring the ancient dance of which we are an inseparable part. And so, dear listener, as we come to the end of our journey through the great breathing of Earth, let us rest for a moment in the quiet wonder of it all. The seasons are not merely changes in weather or shifts in light. They are the heartbeat of our planet, a rhythm that pulses through every leaf, every wave, every breath we take, from the Arctic tern chasing endless summer across the globe, to the phytoplankton blooming in oceanic springs, to the quiet work of soil fungi beneath our feet, to the ancient festivals that mark the turning of the year. Everything is connected in this vast living symphony. Imagine yourself now, wherever you are, cradled by these rhythms. Perhaps you are listening as winter's chill wraps your world in silence, or as spring's first warmth coaxes buds from bare branches. Perhaps summer's long days fill you with energy, or autumn's golden light invites you to pause and reflect. Each season, each moment is a note in the eternal song of Earth's breathing, a song that began with the planet's formation and will continue as long as our world spins through the cosmos. As you drift towards sleep, let this thought be your lullaby. You are not separate from this dance, but a part of it. Your breath, your heartbeat, your dreams, they all echo the great seasonal cycles that have shaped life for billions of years. The same tilt that paints autumn leaves red and gold, that sends whales across oceans and birds across continents, moves through you too. It whispers that there is a time for growth and a time for rest, a time for planting and a time for harvesting, a time for light and a time for darkness. Let the seasons teach you patience, dear listener. They remind us that no winter lasts forever, that every spring returns, that every harvest follows sowing, that every night gives way to dawn. In their gentle turning, they offer a promise. Whatever season you find yourself in, whether in the world outside or in the landscape of your own heart, it is but a moment in a cycle that always turns toward renewal. So rest now, held by the rhythm of Earth's breathing. Let the seasons carry you gently into sleep, knowing that you are part of something vast and beautiful, something that connects you to every living thing, to the oceans and the skies, to the deep time of ice ages and the fleeting beauty of a single falling leaf. Tomorrow, the sun will rise again, and the dance of seasons will continue, as it always has, as it always will. Good night, dear listener. May you dream with the rhythm of the earth, and may you wake to find your place in its eternal breathing song.